Hey pre-algebra class, I hope everything is going well with you. Just wanted to put out a video on the chapter test that we're taking for chapter 9. So before you take the test, hopefully you'll watch this video, you'll find it. We're going to go through a couple of the examples on page 504 of the chapter test that you should be taking to try to give you a good review before the test. Some of you are doing great, some of you are struggling a little bit, but only one of you is asking questions on things that you struggle with. So that's a problem. With this distance learning, I can't see the look in your eyes when you're taking the test, quiz, work, and things like that. So I need you to ask questions. So this is number 3 on page 504. That's part of your work that you'll be turning in before you take the test. And it is 216 equals 2z squared. Basically, it is the same thing like a normal equation. You got to work it out. You got to isolate the variable, get the variable by itself, and see what our answer is. So we have 216 equals 2 times z, so we're going to divide both sides by 2. This will give us z squared on this side. And 216 divided by 2 is 108. Okay, so now we take 108 and we need to figure out how do we get z squared to be just z. Well, we square root it. Square root of z squared is z. Square root of 108. And on this one, according to the book, you can figure it out with the decimal form. It is 10.4 when you round it off. Now, could that be a positive? 10.4 times 10.4, or could it be a negative? It could be either one. So the true final answer is plus or minus 10.4 equals z. So that's how you figure out number 3 there. And let's work on the next one. All right, for our next one is talking about simplifying the expression. This is when they want you to actually figure it out with this radical still involved. The square root symbol is called a radical. So like the previous question, we were able to go 10.4, and that'd be our final answer. Sometimes the book is asking for that. Sometimes when they say simplify the expression, they're looking to have the radical in there as well. So this one you have to start factoring it out. I like to just take prime factors, starting with 2. So 162 divided by 2 is 81. Well, looky there. We know 81 is a perfect square. So we can say that the square root of 2 times 81. Alright, do we know what the square root of 81 is? Well, we know it's 9. So 9 goes on the outside. The square root of 2 stays in. And that is our answer. So we're able to figure it out by factoring and basically figuring out which one has a perfect square in it. We can then take it out, put it on the outside of the radical, and the 2 would stay on the inside of the radical. Now, when you factor these out and you can't come up with something that would be a perfect square, then your answer would just be 162. But when there is a perfect square, you can reduce it down. Now, the next one here, on number 6 on the next one, it is the square root of 20 over 121. Well, we don't know 20 is not a perfect square. 121 is a perfect square. So we've got to work it out. Do we know something that could be a factor of 20 that is a perfect square? We have 2 and 10, 4 and 5. 4 and 5. Well, 4 is a perfect square. So we'd work it out as the square root of 4 times 5 over 121. Now we take out our squares. Well, we have the perfect square of 4 equals 2. Square root of 5 over, and the 121 is a perfect square, it is 11. So we would just work it out, following our formula. It's still 20 over 121. It's 2 to the square root of 5 over 11 as our final answer. Now we're getting into the more fun stuff. I love Pythagorean theorem and trigonometry. We have a right triangle. That's it by the square in the corner telling us that's a right angle. It is a triangle, so it makes it a right triangle. With that, we can use Pythagorean theorem. A squared plus b squared equals c squared. Now, couple things to remember. C is always the side across from the right angle. The right angle is signified by the box in the corner, and so C is always going to be across from it. It is the hypotenuse, it is the long side, it's the longest of the sides, and it's always opposite of the right angle. So C is always that. So we can start plugging in our formula here, and we have A and B as the other two sides. Well, it tells us which one B is, so we can say A is 12. We got 12 squared plus B squared equals 20 squared. So we have 144 plus B squared equals 400. Well, we have to subtract 144 from both sides, and they will cancel there. And we have B squared equals, well, let's do it the long way, 256. Well, then we take the square root of B and the square root of 256. We get B equals 16. So you work it out. You have a regular equation. You just got some squares in there, but you just throw it in like you're supposed to. Square it when you need to. Square root it when you need to. A squared plus B squared equals C squared. So A is 12. So 12 squared plus B squared equals 20 squared. 12 squared is 144. 20 squared is 400. You have 144 plus B, so you got to subtract. Minus 144 cancels there. What you do to one side, you have to do to the other. 400 minus 144 is 256. We get B squared equals 256. Well, to get B by itself, you have to do the opposite. Since you're squaring B, to get the opposite is the square root B. Square root B, get B. What you do to one side, you got to do to the other. 256 squared is 16, and that is how you work out Pythagorean theorem. Right now, we're going to look at 21 and 22, and we have to figure out a full trig problem, basically. Alright, so as a review, the way things are labeled, the A, B, and C are capital letters. And A, B, and C are going to be little letters, lowercase. And their angles will always be opposite the sides. So just again, the right angle is in the corner here, signified by the box. That is angle C, and that is side C, and it'll always be the hypotenuse. So we have side A over here because it's opposite angle A, and we have side B, which is 8, because it's opposite of angle B. This is the angle we're going to be working with, angle 65 over here. And because of that, having just those two information pieces, angle 65 and side of 8, we can figure out the other two sides. So first on 21 it says find the value of side A. Side A is this side. We're looking off of this angle here because this is the information given to us. Is the number 8, side B right here, is it connected to angle A? Yes, it is. So that makes 8 the adjacent side. And side A is not connected and is opposite, and so it is the opposite side. So we're dealing with opposite over adjacent. Opposite and adjacent, that's our tangent. Tangent of 65 equals opposite over adjacent. So as we look here, before we plug it in, this is something equaling a fraction. And a lot of times when you have a fraction like this, the easiest way to work these out is if they're ratios. So if we put that over 1, that's a fraction, and that is a fraction. So we can work those out as tangent of 65 equals opposite, we don't know, over our adjacent. And so now we have a fraction equaling a fraction, we have a ratio. The way that you work out ratios, if you remember, is you cross multiply. So we're going to multiply x times 1 and get x. And we're going to multiply 8 times tangent of 65. So tangent of 65 is 2.44507 times 8. And it gives us 17.15606, which rounds up to 17.2. 17.2. So we worked it out, cross multiply, solving for x. So we're going to do the same thing on the other side, but we're going to use something different. We can't use tangent again because we're looking at a different side. Still looking at this as our main angle, 65 degrees. Still have 8 here, and it's connected to there, so it is the adjacent. And we're looking for C for number 22. So you may say, Brother Vaughn, C is connected to A. Why isn't it adjacent? Because of the first rule. It is a hypotenuse. It is opposite the right angle. Opposite the right angle is always the hypotenuse, and the hypotenuse is always the longest side. So we're dealing with adjacent and hypotenuse. Adjacent and hypotenuse is cosine. So we have cosine of 65 equals our adjacent, which is 8, over our hypotenuse, which is x, and we don't know what it is. Same thing, make it a fraction, and now we have a ratio. We are going to cross multiply. Cross multiply, we get 8 equals cosine of 65. If you don't know, you got to use your calculator. Type in cosine of 65, and it is 0.42218 times x. Okay? How do we get x by itself? We got to divide by that. And do it to both sides. This will give us x over here. And 8 divided by that gives us 18.9 rounded. So sometimes it gets confusing when you're trying to work these out. But if you put it in a ratio and you cross multiply, you always end up with the correct answer. And so the cosine of 65 equals adjacent over hypotenuse, which is 8 over x, because we didn't know what our hypotenuse was. Cross multiply. Cosine 65 times x, so that gives us that number. 8 times 1 gives us 8. So since that is connected to the x, that times x, we must divide by that number. Those cancel, giving us x. 8 divided by that number gives us our answer. And so that is how you will do number 21 and 22. I hope to get another video up pretty soon to do the special triangles and the distance and midpoint formulas.